Hi everyone, welcome back to the Code Street. This is Siddhant, and in this video, we will be trying to understand a problem which is related to searching of elements inside a two-dimensional array. But this method of searching is what I like to call as staircase search or stairwell search. जिसमें कि what we do is we find an element inside a two-dimensional array. But the catch is that the two-dimensional array is row and column wise sorted, which means that each and every element inside the matrix or the array, two-dimensional array, is sorted in a row and column wise manner. So how do we eventually find out an element inside such an array, and what is the way of finding it out, and what is the algorithm or what is the thinking pattern when we encounter such problems? That is something that we should be learning in this video. And yeah, so do stick around till the end and we shall eventually solve it together. So before we can start off with this video, let us get to know a bit more about Newton School. So Newton School is an Edtech platform which guarantees you 100% placement without charging you a single rupee as fee until and unless you get placed with a minimum package of 5 lakh per annum. Newton School is doing this initiative with a number of really great companies which can be found out on their platform. And Newton School does this by offering a number of really great courses which are designed for women, for working professionals, and even full stack development courses. All you have to do is just enroll into these courses, and after completion you will be completely job ready. In the recent times, Newton School has started off with a launchpad program under which it is giving away a number of really great courses entirely for free. All you have to do is enroll into these courses and get the knowledge, and upon completion you will be getting a course completion certificate, and the instructors are also the best ones out there. In the meantime, if you feel like any coding related activity has to be done, you have to just go to Newton School's playground area and you have to create your own algorithmic playground, and you can just get started with your choice of language. That is it, and that is how we do it. So with that being said, let us come back to today's video, and let us get to know how do we go about solving staircase search. So the question at hand is, we have to find an element. We have to find an element inside a row and column wise sorted array, sorted 2D array, right? So this is something that we have to do inside a 2D array which is row and column wise sorted. And for example, the array that we have at hand is something like this. One, 4, 8, 10, 5, 16, 11, 17, 9, 15, 18, 19, 20, and 23. So this is how a row and column wise sorted array looks like. Now the thing is that how do we go about solving the problem? So the thing is, देखो ये array जो है ना, ये row and column wise sorted array. So what is the first thing that comes to your mind when we see a two-dimensional array which is sorted in a certain fashion and we have to find an element inside it? Let us just forget that it is row and column wise sorted. The first method of doing this is, भैया एक लूप, दो लूप चला देते हैं, एक रो के लिए लूप, एक कॉलम के लिए लूप, एंड देन इवेंचुअली वी विल जस्ट फाइंड आउट इफ ईच एंड एवरी एलिमेंट, go about solving and traversing the entire array and finding out whether each element is equal to my key element, and if it is, then it will return true. If it is not, it will not return false. So this will be the brute force approach. Brute force approach is always a bit risky in comparative coding, because brute force approach always lands up with the probably the worst time complexity. And in case of competitive coding, there are huge number of inputs. Like the input can range between 1 till n till less than equals to 10 to the power 5, which means that if you have an n square complexity, so 10 to the power 5 square means it will be an immensely huge time complexity. Like those number of iterations have to be done, and it will be very poor solution to a problem. So brute force approach is good for initial thinking, but not for practical implementation. Second thing that we can do is binary search. That is also a very good approach. Binary search, for the worst case scenario, that is worst time complexity that it will give me, is O of n log n, isn't it? Binary search will give me the O of n log n time complexity for the worst case. So third case is this one, staircase search. So what happens in staircase search is, understand now, understand very carefully, row and column wise sorted array. Sorry. So row and column wise sorted 2D array means the minimum element inside the array will be in the top left corner, and the maximum element inside the array will be in the bottom right corner. Is it not? Is it not? So what if I consider these two elements as my marker elements, or as I call it, the two-pointer approach. These two elements are my tracker elements. Okay, I, J. Alright. Now what do I do? There are 0, 0 से लेके m minus 1, n minus 1. Okay, these are my rows and columns inside the array. Now there is a key element that I have to find out. Okay, now what I do is I run this loop. Okay, and each time I find out whether this element, this and this, we have both these things. Okay, whether my current element is, we can either begin the search from here or at the top left or at the bottom right. So is my current element is equals to key or not? If it is less than key, it means that I have to do I plus plus, I have to bring this ahead towards right. Alright, that is it. If it is not, then what I have to do? If it is less than, then what I have to do? I have to bring it towards the right so that the value becomes greater. If it is greater than, then what I have to do? I have to bring it towards the left so that the value becomes lesser, isn't it? Left में आ जाएगी value, less हो जाएगी. फिर we can also move it top and below as well. ऊपर भेजेंगे वैल्यू कम होएगी, नीचे भेजेंगे वैल्यू ज़्यादा होएगी, है ना? तो वो भी हम कर सकते हैं. And eventually by moving it left, right, above and beyond, above and below, what we can do is we can eventually find out if the element is equals to the k element that we are searching or not, isn't it? So this is how we will be doing, by simply understanding that in a row and column wise sorted array, the element which is most minimum is in the top left corner, and the element which is the maximum is in the bottom right corner. Understood the fact? So this is how we go about progressing inside a staircase search, and yeah, that is it. So the code for the same will be below as I write it. So header files. So after the header files, what are the basic initial elements that we have to take? Int I equals 0, int j equals n minus 1. So these are the first two things that I have to take. 0 and n minus 1. Okay, m minus 1 लेते तो कौन सी एलिमेंट आती? ये वाली आती. ठीक है. I hope that you are clear with these things. What is m minus 1? What is n minus 1? And after that, of course, the elements. Why is it not writing? So then we will take the int key, that is the number that we have to search. We will take the key element, and after that what we do is we accept the array. Okay, what we will be doing is we will be accepting the array. So accepting of the array is very simple. I equals to 0, I less than m, I plus plus. I will mention it here. Now, how do we go about searching the element inside the array? So for that, what we have to do is we have to again run the loop, and we have to run if my row is less than m and my column is less than n, that is m rows and n columns are there. So if my row is less than n and if my column is less than n, then what I do is it's creating furore. It's not running. If my key element matches with that of the a of ij, that is if a of ij, that is my current element, matches with the key element, then what I can do is I can also include a flag value here, है ना. फ्लैग की जो वैल्यू होती है उसको 0 रखते हैं अभी. If it matches, it means that flag is 1. We break it. Okay, काम खत्म, हमें मिल गया है हमारा एलिमेंट, राइट. एंड इफ इट इज नॉट, इट मीन्स दैट हमारा ये हो गया, हमारा ब्रेक हो गया है यहाँ पे. else what we do is flag is equals to 1, we break it. Else if a of ij is greater than key, it means j minus minus, else I plus plus. That is it, I guess that is it. That is it. Yeah. And once we are done with all this, what we have to do finally is that we have to check that अगर हमारी flag की value, if after all this is over, like entire array has been traversed and my array has still not been found, my element has still not been found, it means that if flag is still after the entire traversal is 0, it means that my element was not there. Element not in the array, or any susceptible message that you can like write it here. So that is it. It is pretty simple, just like the two-pointer technique that I taught you to use. That is how we should also solve this problem as well. It is just that it should click inside your head that when and where to use the two-pointer technique. It is a very efficient way of solving a lot of really great problems, but it should be like dependent on you where and how to use it. So since it was row and column wise sorted, we could have easily used the two-pointer technique, and here it is. So up until the next video, I hope that you take utmost care of yourself and don't stop coding. I will be back with yet another brilliant problem in the next video. Bye bye.